Hello there, Nareg is here, and today I'm going to talk about how to solve parametric quadratic equations. So in this case, I'm going to take directly a few examples and we're going to solve these equations, discuss about these equations together. So let's start. The first equation is x squared plus 2 times m plus 1x plus m squared plus 2m plus 3 is equal to 0. Now, as you can see, the first thing that you should check is the coefficient a. A is 1, it's not parametric, so this equation will remain quadratic no matter what the value of m. So, you calculate, the second step is to calculate delta. Now your b is even, so why not calculate delta prime, the reduced discriminant, which is equal to b prime squared minus ac. So it's equal to m plus 1 squared minus a is 1, c is m squared plus 2m plus 3. So I will expand m squared plus 2m plus 1 minus m squared minus 2m minus 3. So m squared minus m squared, they will cancel out. 2m minus 2m, they will cancel out. So whatever remains is a real number in this case, which is minus 2. Delta prime is negative. What does it mean? It means that this equation, no matter what the value of m, it will have no real roots. No real roots, no matter what the value of m belonging to the real numbers. All right? So this was the first example. Now let's take the second one and discuss about it. The second example is x minus 4 times x minus 6 plus m x minus 5 is equal to 0. I will have to expand it, so it's x squared minus 6x minus 4x plus 24 plus mx minus 5m is equal to 0. I will have to arrange it. X squared plus x m minus 10 plus 24 minus 5m. Again, this equation is quadratic no matter what the value of m, because my coefficient a is 1, so it does not depend on the parameter m. So I will have to go through the calculation of delta. What about delta? Delta is equal to b squared minus 4ac. b is m minus 10 to the power of 2 minus 4 times a is 1, c is 24 minus 5m. So I will have to expand it. M squared plus 100 minus 20m, so minus 96 plus 20m. Minus 20m plus 20m, they will cancel out. It's m squared plus 4. Delta is parametric, but as you can see, it's m squared plus 4. M squared plus 4 will remain strictly positive no matter what the value of m. So whenever delta is positive, it means that in this case, since delta is positive, I will have two real distinct roots no matter what the value of m from the real numbers. What are these two roots? Now, in order to calculate the roots, you simply use your formula. So x1 is equal to minus b minus square root of delta over 2a. So it's minus m plus 10 minus square root of m squared plus 4 over 2a, it's 2. x2 is equal to minus b plus square root of delta over 2a is equal to minus m plus 10 plus square root of m squared plus 4 over 2. Alright, so these are actually the roots of this parametric equation. Let's take A third example. Now, in this case, the equation is x squared minus 2mx plus m times m plus 1 is equal to 0. So again, this equation will remain quadratic no matter what the value of m. Since the coefficient a is 1, it's different than 0 and it's not parametric, so I will have to calculate delta. In this case, I will calculate delta prime because b is even, so it will be equal to minus m. Let's use the formula first. Delta prime is equal to b prime squared minus ac. So it's minus m to the power of 2 minus a is 1, c is m squared plus m. So it's m squared minus m squared minus m squared minus m squared, they will cancel out, it's minus m. Delta prime is minus m, it's parametric. So in order to find out whenever delta prime is positive or negative, you will have to say delta prime is equal to 0, which means minus m is equal to 0. So m is equal to 0. And I will have to do like a small table, a table of sign. So m, whenever going from minus infinity to plus infinity, passing through the value of 0, delta prime, which is of course minus m, will be equal to 0 whenever m is 0, and it will be negative on the right side, positive on the left side. So from this table, of course, I can deduce that delta prime is positive for m belonging to from minus infinity to 0. Delta prime is 0 for m is equal to 0, and delta prime is negative for m belonging to the interval from 0 to plus infinity. So this is what I should write down in the part of solution in order to solve it. So I will have to say whenever m belongs to minus infinity to 0, I will have two real distinct roots, and I should of course calculate, you use the formula of course, x1 is equal to minus b prime minus square root of delta prime over a, so it will be equal to m minus square root of minus m over a, which is 1. x2 is equal to minus b prime plus square root of delta prime over a is equal to m plus square root of minus m over 1. All right. Now, what about whenever m is equal to, whenever m belongs to the interval from 0 to plus infinity, I will have no real roots. No real roots. And whenever m is equal to 0, which means delta prime is equal to 0, I will have one real double root. And of course I can calculate that double root. It will be equal to, let's say it's x1 is equal to x2 is equal to minus b prime over a. So it's equal to m. And you replace m by 0, it will be 0. All right, so this was our third example. Let's go to the fourth example. The fourth example is m x squared plus 2 m minus 2x plus m is equal to 0. Now in this case, you first start talking about the coefficient a. So you say whenever m is equal to 0, your equation will be transformed to 0x squared plus 2 times minus 2x plus 0, which is equal to 0, which means minus 4x is equal to 0, so x is equal to 0. It will be a linear equation, you can solve it directly. Now, whenever m is different than 0, the equation will be quadratic, so it will remain quadratic. You will have to pass through delta. In this case, again, I'm going to talk about delta prime, which is equal to b prime squared minus ac. B prime is m minus 2 to the power of 2 minus a is m, c is m, so it will be equal to m squared plus 4 minus 4m minus m squared, so it's equal to minus 4m plus 4. Again, our delta prime is not a real value, it's not a constant which is positive, negative, or 0. So I will have to discuss regarding the values of m. In order to discuss about it, I should say delta prime is equal to 0. So delta prime is equal to 0, which means minus 4m plus 4 is equal to 0. Minus 4m is equal to minus 4m is equal to 1. And I will have to do the table of sign. So m going from minus infinity to plus infinity, passing through the value of 1. Delta prime is equal to 0 for m is equal to 1. And then you have, in this case, negative, and here you have positive. All right. Of course, in order to discuss about the existence of roots, you simply have to say whenever m belongs to the interval from minus infinity to 1, of course delta prime is positive. All right, so delta prime is positive. Okay. When delta prime is positive, you will have two real distinct roots, and you have to calculate them, of course. You simply use the formula x1 is equal to minus b prime minus square root of delta prime over a, so it's equal to minus m plus 2 minus square root of minus 4m plus 4, all right, over a, which is m. As for x2, it will be minus b prime plus square root of delta prime over a, so it will be minus m plus 2 plus square root of minus 4m plus 4 over m. Now, what happens when m belongs to the interval from 1 to plus infinity? You will have no real roots, And as for the case of m is equal to 1, you will have one real double root. You can of course calculate that root. x1 is equal to x2 is equal to minus b prime over a is equal to b prime is minus m plus 2 minus m plus 2 over m, and of course you will have to replace m by 1, so it will be equal minus 1 plus 2, it's 1 over 1, so it's 1 as final answer. So this is how you discuss parametric equation, and you will be able to solve it. I will take one last example where the delta, it will be from second degree, and we're going to discuss that case. So here's the example. So if we have 2m x squared minus 8x plus m minus 5 is equal to 0. All right. In this case, I will have to calculate. You can say, of course, whenever m is equal to 0, the equation will be transformed to 0x squared minus 8x minus 5 is equal to 0, which means minus 8x is equal to 5, x is equal to 5 over minus 8. Again, it's a linear equation. Now, whenever m is different than 0, what happens? You will have a quadratic equation, so it will remain second degree, and of course you will have to calculate delta. In this case, delta prime is b prime squared minus ac, so it's equal to minus 4 squared minus a is 2m C is m minus 5. So it will be equal 16 minus 2m squared plus 10m. The equation will be minus 2m squared plus 10m plus 16. As you can see, delta prime, again, it's not a real number. It's not first degree. First degree, we can't solve it easily. So in this case, you will have to go through delta of your delta. So it's the delta parametric. So let's calculate delta prime. I will say delta prime of m is equal to b prime squared minus ac. As you can, if you can remember, b is 10, b prime is 5, so it will be 5 to the power of 2 minus a is minus 2m minus 2, and c is 16, so it will be minus 2 times 16. It will be equal to 25 plus 32. It's 57, which is positive. What does it mean? It means that this equation actually has two distinct real roots. So what are these roots? m1 is equal to minus b prime minus square root of delta prime over a. So it's minus 5 minus square root of 57 over 2. m2 is equal to minus b prime plus square root of delta prime over a. So it's minus 5 plus square root of 57 over 2. Now, once you have done this, you will have to go through a table of sign. So the table of sign will be for m going from minus infinity to plus infinity, passing through. The values are, I'm gonna simply say that this is m1 and this is m2. m1 is smaller than m2 because it's a negative 1. Alright, so delta prime will be 0, 0, and then you will have to check it's minus 2m squared, so it will be positive in this place, in this region, negative outside m1 and m2. Once you have done this, you can also say that your equation will have, for m, which belongs to the interval minus infinity to minus 5 minus square root of 57 over 2 union minus 5 plus square root of 57 over 2 until plus infinity, no real roots. When m belongs to the interval m1 until m2, the values I already mentioned, you will have two real distinct roots, and of course you can use the formula. And when m is equal to m1 or m2, you will have one real double root. Whenever it's one real double root, it means that x1 is equal to x2 is equal to minus, we use delta prime, so it's equal to minus b prime over a, and of course here you can calculate your value. Alright, this is how you discuss about a parametric quadratic equation. That's all for this video. Why not subscribe to my channel? I will upload new videos and you'll be notified. I can also share with you my Instagram and Facebook account in case you want to contact me directly, or you can simply leave a comment below. So I hope it was helpful and see you next time.